Let's take a look at error handling, which is a way for programmers to catch and gracefully handle errors that may occur during program execution and prevent the program from crashing. Some key features of error handling are the exception, which is the error that occurs during program execution, the try except block, which is a block of code that catches and handles the exception, the except statement, which specifies the type of exception to catch, the finally block, which is an optional block of code that executes regardless of an exception happening, and the exception type. Python has numerous built-in exception types and it allows programmers to create custom exceptions. Over here on the right side of the slide, I have some syntax examples. We have the try keyword followed by a colon, and then below it, it's indented code to execute that may raise errors. And then we have the except keyword with a colon, and below it is indented code that will gracefully handle the error should they occur. And then below that, I have another example. This one next to the except keyword has a specified error, the zero division error. And then we have a finally keyword with a colon that has indented code underneath of it that will execute regardless of if an error has occurred. If I jump into my development environment, I can show you that I have a variable here that is set to be equal to 10 divided by 0. And if I try to execute this program, we'll see that I get an error, zero division error, and it's giving me a message division by 0. You cannot divide a number by 0, so this raises an error. So to handle this in a way that the program won't crash, we would use a try except block. So now I have a try keyword followed by a colon, and then indented underneath of it, I'm saying x equals 10 divided by 0. And then I have an except keyword. And instead of crashing the program, this is what I want to happen should this error arise. So when I run this, I get this output of, oh no, something went wrong from my except block. However, this is not exactly a very helpful statement should an error arise, so we can do exceptions for specific errors. So here I can put in the error that I'm looking for, such as the zero division error, and then underneath this, I can give a message like, you cannot divide by 0. And now when I run this, I get this message, you cannot divide by 0. But what happens if that's not the only error in this code? Let's say that I have a list, and I'll give it the values 1, 2, and 3. And then let's say I try to access that list and say z equals my underscore list, and I give it the index of 3, which this list only has indexes 0, 1, and 2. So index 3 does not exist. Well, if I run this, you'll see that my program crashed and it's giving me an index error telling me that the list index is out of range. So to handle this, I could put these errors in parentheses and pass in another error here. And now I have to modify my message because it's not only catching the zero division error. So I'll have it say you cannot divide by 0 or use an index out of range. And if I run this, now it catches that index error and it says you cannot divide by 0 or use an index out of range. But now I'm faced with another problem that I don't know which of these two errors is happening, so I won't know how to fix my code. So you can have multiple except statements. So I'm going to fix this, have it give me an except statement for the index error and an except statement for the zero division error. And now I can have you cannot divide by 0 under the zero division error and have it say you cannot use an index out of range under the index error. Now if I run this, I'll get the you cannot use an index out of range. And if I swap this here to be up at the top of my try block and run this, now I will get the division error. So you cannot divide by 0. And that is because the first error that is encountered underneath the try keyword inside the try block is the error that causes the exception. So even though there is a index error down here, this line of code right here is causing the error. So these two lines of code never actually execute. But I may still have a problem here. There may be other errors in here. So I may try to pass in a variable name that doesn't exist for my list here, and this will cause a name error. But I don't have an exception down here, and I may not know that that's even a possible error that can happen. So what I can do to help solve that issue is put in an except down here that kind of catches all. It catches any error that happens, and I can give it the output of, oh no, something went wrong. And now if I were to swap this be on top so that my name error happens. I'll get this output, oh no, something went wrong. But that's not very helpful. It doesn't really tell me what's going on. So the way that you can have a catch-all exception but actually have information about the error is by using the general base class of exception, but you also have to use the as keyword and then give it a variable name. And by convention, it's typically E, which is short for exception. Now this here is the common base class for all non-exit exceptions. So this is the base class for zero division error, index error, name error, anything that's a non-exit error. So now, because I'm using this as E, I can access the attributes of this. And down here in the print function, I can say error, give it a colon, and then a comma to separate my values and pass in E. And now when I run this and I get this name error, down here, I'm going to get the output error name Y is not defined. So now, with this catch-all, I can actually get information about any errors that happen that may not be a zero division error or an index error. And then I can have a finally block. And this code here will run no matter what. So if I wanted to, I could put in print done checking for errors. And if I run this, we'll get the output with my error, and then we'll get the output done checking for errors. Then just to show that it works, if I go up here and I remove any of my errors, so let's go ahead and get rid of all that error code. I'll just create a list in there. If I run this again, we'll see that I still get my done checking for errors output from my finally block, even though none of these errors happen.